Hello, my name is Jean-Luc. I am in CPU 100 Lab, Section 1002, and my project is a Morse code translator and game. So my project is a Morse code decoder. It has two modes, a translate mode and a game mode. The modes are toggled on and off by a switch. When the switch is off, which is the default case, translate mode is active. When the switch is on, which is not the default case, the game mode is active. There are 4 user entries. There are the Morse code values, the dot and dash, the next, which enters the Morse code value, each bit, enter, which means that you've entered all the bits that you want, and reset, which just resets the entire system. So for the translate mode, the user inputs the Morse code sequence through a switch. After each dot or dash is entered, the user must press the push button, the next push button, to register the input. When the switch is off, that means a dot is entered, but when the switch is on, that means a dash is entered. I will show that in my demonstration. Once a sequence is entered, the user will turn on a slide switch, indicating that the entire sequence is entered. So that's the entry. That means that you've entered everything that you want. When the sequence is fully entered, and if a sequence is detected, the letter that corresponds to the Morse code value entered will display, if one is found. If it's not found, then nothing will display. Then you just have to reset your system and try again, or switch modes. Once the sequence entered is displayed, you can reset by flipping the reset switch on or off, or the user can enter another Morse code sequence, or switch modes to the game mode. The game mode is where the user must guess the correct sequence for a given number or letter displayed on the 7-segment display. That's the letter that you have to guess the sequence for. If the sequence that you enter corresponds to the same letter displayed on the 7-segment display, good will display on the 4 left-hand side 7-segment displays, showing that you got it correct. There are 16 levels toggleable by 4 switches, so kind of like binary. So if 1 and 4 is flipped on, level 9 will be playing. The user can reset the game by flipping the reset switch on, and then you can either enter another level or enter another guess for the same level you're on, or just switch modes completely back to the translate mode. The goal of this project was to create a device that translates user entered Morse code and show it on the 7-segment display. And then I also added the game mode, which is the exact opposite. The user enters the sequence corresponding to what is displayed on the screen. And I kind of combined these two ideas. They both have the same theme. They're both Morse code related into the same project, even though they're kind of antitheses of each other. So for background theory, I used a lot of D flip-flops in my my project. For counting the number of bits entered, D flip-flops were very important then, because some Morse code values are 1 bit, some of them are 4 bit. So I don't always exactly know which one is going to be more appropriate for the combinational logic in determining whether or not the Morse code value entered is valid or not. It's also very good for storing dots and dashes, storing the inputs that are used. Obviously, it's memory. And then also, I shifted the dots and dashes through my system. I'll show that in my schematic using shift registers. I use AND gates a lot to check whether or not the sequence entered corresponds to a letter. You'll see that in my schematic. And I use a lot of OR gates because OR gates are very useful in displaying the letters on the same display. So they don't each have to have their own display and LED. This is the basic Morse code detector. A through Z. This is what I use for my combinational logic to figure out what the combinations are corresponding to. This is my schematic diagram. So it's very large, very involved. Instead of showing it in the presentation, I'll just show you my actual schematic. So here are my 4 inputs, as I described earlier. Input, next, enter, this is dot or dash, reset. This is the switch 3, that toggles game mode on and off. This counts. This doesn't count. This stores the dots and dashes, the user inputs. This stores the count of how many bits this is, and this is the combinational logic for the translate mode from A through Z. And if the combinational logic is true, then it goes down here and it outputs to the 7-segment display. There's 7 of these outputs. Down here is my game mode. These are my 4 switches, which determines level. These are the combinational logic for the level, determining which level that the user wants to go to, and then that goes to each of the same sort of concept here, the user entry and then the counter. Each of these levels has their own because they're all unique letters, and there are 16 of them. And then once those are entered, if it comes out that, okay, the sequence that the user entered is correct, it goes down here and it displays good. This is good. This is the logic for good. This is now my circuit operation. So as you can see here, I create a video of my circuit operation. I'm showing the reset, how there's an LED for the reset. The reset's on the left. That push button is the next button. It's the clock. This slide switch is off its dot on its dash, and then that switch is the enter switch. As you saw, an LED popped up when the enter switch was on. So now I will enter, I think, I'm not sure what letter I enter here. I think it's A, maybe? Yeah, I enter A. So that's dot and dash. As you saw, I entered dot and dash, and then it displayed on 7-segment display. Now I'll enter a different combination. I'll enter Z, which is a 4-bit as opposed to the 2-bit A, and it'll also display on the screen. It automatically detects the sequence that you enter. Now I believe I move on to the game mode. Skip a little here. I just show all the different game options. I'm going to try F on the game mode. F is shown on the screen. Now I have to enter the combinational logic for F. Actually, I'm going to try J. So now I have to show everything. I have to enter the combinational, not the combinational, the Morse code sequence for J. And then once I do that, as I show here, J is dot dash dash dash. That's what I just entered, and then good is shown on the board. Some interesting information I found. Shift registers were very helpful for data entry, as I said earlier. Did not know how exactly many bits entry would be, so by tracking how many times shift happened, I was able to accurately have the number of bits that were entered. And also, I kind of learned Morse code because I worked with it so much. So in conclusion, I implemented my own personal project on my D0 board. It both translates Morse code input into letters, and then the game mode, you enter the Morse code for the letters shown on screen, and it checks if it's valid. I use my skills taught during the labs and everything, and that all kind of culminated into creating my decoder. And I used concepts ranging from combinational logic, so AND gates, OR gates, to shift register and D flip-flops, which we just learned recently. So I implemented a wide range of skills.